Oh, hmm. Could you? I gave you one question to solve. Huh? Did you solve this question? You haven't solved this one. Try solving it now. Someone connecting. Oh,
Sir, could you solve it?
A, C. How do we solve this one? Here, a rod of length L is placed along the x-axis between x is equal to 0 to x is equal to L. The total length of the rod is L, capital L. Mass density means mass per unit length. Rho is given to be A plus Bx. A and B are constant. Find the position of center of mass of this rod. We know the center of mass, x center of mass formula is integral x dm by integral dm. Okay, na? According to the limits. What we do here, we actually assume an element of length dx. हाँ राधिका.
तो मास में आ रहा है AL plus CL square upon 2.
अच्छा मास तुमने निकाल लिया है. AL plus PL square बेटा. हाँ ठीक है. तो ठीक है.
तो लाइक पहले यूनिट निकाल दिया मैंने उनका एंड फिर इंटीग्रेशन से सॉल्व कर दिया.
हाँ वो तो ठीक है, पर एक्स सेंटर ऑफ मास निकालना है ना. Now what happens, mass dm you have to find. Dm mass will be rho, which is mass per unit length, into the length of the element that you have taken, dx. Okay, so this will be rho is a plus bx, so dx, this will be your dm. Now put it here, limits will be 0 to L. 0 to L, x dm is a plus bx into dx divided by integral a plus bx into dx, 0 to L. Now this will be ax plus bx square dx, 0 to L, whole divided by, this will be ax plus bx square by 2. I have integrated 0 to L. So now this will be ax square by 2 plus bx cube by 3, 0 to L, whole divided by ax plus ax square by 2, 0 to L. Now if you put it, these integration, it will be al square by 2 plus bl cube by 3 whole divided by al plus pl square by 2. Now what you can cancel out? You can cancel out L at least. L, this will be L square, L. So the final answer you should get is L, I'll take common, 3a plus 2b L divided by 3 into 2a plus bl. This should be your x center of mass. See Haripriya, it was actually easy, not difficult.
Sir, I didn't get to know which to integrate.
See, the integration formula is x dm. The actual thing is, whenever you have to find out the center of mass, means here see, along y nothing is changing, only along x things are changing, so you will have to use this formula. So first you have to find out dm. For finding out dm, what we take an element. See, find the formula is this. For finding out the dm, you have to use this element. Take an element of length dx and then use mass per unit length. Okay.
Yes.
That's the normal method, which actually we use it in every case. There are different cases also. Suppose if someone asks you to find out the center of a use, by now you have learned it's sir easy. It's very easy to find out the center of mass of a linear body. Means like say, like for a rod it is very easier, but for a rectangle body how we'll find? For a rectangle how we'll find the center of mass? For this, how sir, for this, if you get the doubt sir, for this how we'll try to find out the center of mass, and if the length and breadth they both are different, and in this particular case how will we take the elements? Yes, now that should be a particular doubt. Let me just show you how you will integrate here. Here, because things are changing along the x-axis and y-axis also, so you will have to use two formulas. X center of mass is integral x dm by integral dm, and for y center of mass you have to use integral y dm by integral dm. Limits you have to put accordingly. See, there are different ways. It's up to you. You can take an element, because things are changing along the dx as well as dy, so you can take an element of length dx and height dy, breadth dy. Okay, but in this particular case, when we are trying to find out the mass of this particular element, we have to take mass per unit area. So the mass dm in this particular case for this will be rho into dx dy, where what is rho? Rho is the mass per unit area, areal density we say, which will be capital M, or if I have given the mass of this as M, will be M by AB. Get it? I'm just trying to show you along the one axis you have known how to find out, but along a planar body how do you find out this? How you use this process of integration to find out the center of mass? Now here dm is rho dx dy. Now see, if we use x center of mass formula, it will be integral x dm will be m by ab dx dy by m by ab dx dy. Okay, but in this case remember you are trying to find x center of mass. So what is changing? X is changing. Only this thing is changing, x. Finding out mass is okay. See, this, even without integrating, I can put this value as small m, because it represents the total mass, and total mass of the body is m only. So need not integrate. In every case, I can write this m, because why to put burden? We can just integrate it. We can just put the value because it's represent total mass. Now, when we are finding x center of mass, the thing that is changing is x. Okay. So now x will be from 0 to a. Now the integration will be m by ab, dy will come outside, 0 to a dx. Acha, I will not put it like this. I will integrate it, otherwise dy won't cancel. Here also things are changing along the x-axis only. Here in denominator, so we'll do 0 to a.
Sir, what happened to the x?
X is changing, so we are taking it inside the integration. Y is not changing, so that's why we have taken outside.
X dx, no sir, inside the integration.
Sorry, I missed it. Okay, now it's okay now.
Yes.
Yes, in the similarly the denominator x is changing from 0 to a, so dy will be is a constant, it will come outside. So 0 to a dx. Now these things will cancel. It will be what? X square by 2, numerator 0 to a, x 0 to a, so it will be a square by 2 divided by a, so a will cancel, a by 2 is coming. So your center of mass is at a by 2, x center of mass is this. Now finding out y center of mass, for y center of mass we'll use this integral, but now y is changing, x is constant, so y m by ab dx dy, y is changing from 0 to b, 0 to b m by ab dx dy. Now y is changing, x is constant, for finding out the y center of mass. So what we'll do, we'll put y inside, so m by ab dx 0 to b y dy divided by m by ab dx 0 to b dy. These things will cancel out and it will become b square by 2 divided by b, so it will become b by 2. So you know na, x center of mass comma y center of mass, what you have got, it is a by 2 comma b by 2. That is why, because of this calculation only, that's why we say the center of mass lies at the middle point. This is b by 2 and this is a by 2. That's how we integrate. There are other ways also. Students or the peoples or the teachers, they integrate it different way also. The other way is C. The method 2 is what they follow. They make rods. One way is this. The other way is the rod of this. They take constant length, because in the above result you have found out the center of mass of the rod lies at the center. So they just take this mass dm is equal to the length a into dy, they take a dy is area m by ab. And because they know for a rod this x center of mass is only at the center, so it will be at a by 2 only. But for y they just integrate. The second way is I'm just doing it using this formula, method 2. Let me write it with a different pen. It will be integral. Let's say it is at y distance, y a dy m by ab by total mass is m. Zero to b. So it will be m by ab. This cancel. A cancel. M by b will, these will cancel because they will come outside. So integral 0 to b y dy by 0 to b dy. We'll get the same answer, b by 2. That's another way that they use. Means they actually use the prior result that you have got. the mass of for a uniform body, the center of mass rod center of mass lies at the center. Like that also they do. But if we do not know anything, I'm taking from scratch, we do not know anything, then in that particular case you will be using the method one that I have just told you. Clear? No? See, this will be a bit confusing for you initially. Because why? Because you are not very much comfortable in integration part, and doing this one or two times, if you analyze by yourself, you will be easy for this one here. But important thing is, did you understand this or not?
Yes, sir.
Shiva understood. What about others? Haripriya, okay? You understood?
Yes.
Radhika, Kanishka?
Yes, sir.
Okay. This is how we find out the center of mass for a uniform body. Now see, there are few results that I have noted down. These are few results that actually, see, I have told you, I have shown you how to find out, but it's not needed actually. The integration part you can skip also, but these basic integrations you should know, like this question they have given. Na? The complex integration they won't ask. The planar bodies they actually do not ask. These results I have given. These results, it's better if you remember, it's good. Center of mass is a uniform rectangular, square or circular plate lies at the center. This you already know. Semicircular ring, this result is important. For a semicircular ring, this one, the center of mass lies at the center and 2r by pi. This result is important. If you want, I can show you how it came. For solid body, it is 4r by 3 pi. For hemispherical shell, this one you remember, because integration will go 3D. It's not recommended that you know this one. R by 2, 3r by 8. Just remember the result. I can show you for these planar bodies if you want. Do you want? Or you can try, you want to try yourself? हैं राधिका, क्या कह रहे हो? हाँ दिखा सकता हूँ, मैं क्यों नहीं दिखा सकता? See, I'll show you how to find out for a semicircular ring.
तो एक सेकंड के लिए वो वाला टेबल दिखा सकते हैं?
क्या दिखाऊं? ये
सॉल्वेंट है
नहीं समझ में नहीं आया राधिका, क्या देखना
अरे
चाह?
मुझे सॉलिड हेमिस्फीयर का देखना है।
सॉलिड हेमिस्फीयर का? अच्छा, 3r/8 है।
ओके से
ठीक है, अभी ये दिखाता हूँ, देखो। सेमी सर्कुलर रिंग, how do you actually find out? But see, again I'm telling, this is not important. Derivation part is not important. The why we are learning this is only to know if they ask any tough question in advance, we will be able to find the center of mass. Let me draw the ring. This is your ring. What I'm doing is I'm taking one element, and suppose the radius is r. Suppose this element is subtending an angle of d theta at the center, and suppose it makes an angle of theta here. Clear? Now x center of mass we need not find, because x we know, because this is a symmetrical body. This x part will be at the center only, this line only. It will be lying at the center. When when the body is symmetrical, the center of mass line lies along a line, cutting it in half. But we do not know about y because the lower part is missing. So dm will be what? If we take the total mass as m, you know this one, na? The arc length will be r d theta. For Haripriya, I know Haripriya, Radhika, and all Haripriya, Radhika. They will be knowing. Shama is not there in class today, but they all know. But what about Diva and Kanishka? Do you know the arc length is r theta?
Yes, sir.
You know, na? Kanishka, you know?
Yes, sir, I know.
You know, na? Huh. See, this is r theta. Now, if the total mass was m, mass per unit length, what is this? Pi r. Pi r is this. Now I have found out rho, mass per unit length, for a ring, because the semicircular, this circumference is pi r. Now the total mass of this dm will be m by pi r into r d theta. And we are concerned with only y. So integral y center of mass we have to find, because x center of mass we already know, it is at center here along this line, will be integral y dm by integral dm. But y is there, dm is m by pi, rr we will cancel, m by pi into d theta. Now here comes the problem. Problem is, here we have the variable as theta, but y is different. So we have to find out y in terms of theta. And you will be able to find out very easily now. Because this is y. Y is what? R sine theta, na? So I'll put it here. M by pi integral r sine theta d theta divided by integral dm. It is integral dm is m by pi integral. Let me write the result, or you can just write m only, not a problem. But let me do it like this. Now you have to put theta. See, when we are integrating from one end to the other, theta is changing from 0 to pi. So we have to put the limits accordingly. This will be what? mr by pi. What is integral of sine theta?
Minus cos.
Very good. These results you should remember. This will be m by pi will come outside, theta 0 to pi. I don't know we'll get the result, but trying. mr by pi minus will take outside. Let's take minus outside. Cos pi, cos theta 0 to pi by m by pi into pi minus 0. Let be minus mr by pi. Cos pi is minus 1. Cos 0 is again 1. So minus 1 divided by m by pi into pi. Pi will cancel. Will cancel again. We are getting 2r by pi. We have got na y center of mass is 2r by pi. I think this was the result, 2r by pi. Is it difficult?
a little bit difficult.
Why it is difficult for you now? Because these things are new to you. That integrating. I'm doing it very comfortably, changing Y with this. You must be having some doubts because see, you will be comfortable in this if you are very good in integration part. In integration part, we have to remember whatever variable we are taking here, theta, we have to put everything else in that variable only. That's why I have converted y in terms of theta. Otherwise, there was no point converting it into theta. Rest all things go that way. Rest all things are easy. Just the application of this formula. Now see, the semicircular ring is okay. If I ask you to do for the semicircular disk, how you'll do? Can you suggest something? What about this semicircular disk? Anyone? Radhika, Diva, anyone?
So can we like do this using rods, or it will be very inefficient?
See, just like rods, na, here in this particular case, we have to consider rings. Because for ring, the result you already know. Just assume the thickness is dr and the radius is r. Small r. We know the center of mass of this lies at 2r by pi here. For this ring of length dr. Okay. So, what is the mass of this? M sigma rho is m by pi r square by 2. 2m by pi r square. The mass of this will be rho in dm will be rho into pi small r into dr. 2m by pi r square pi small r into dr. 2m r by capital R square into dr. This is the mass m. Now it's very easy now. Center of mass will be y center of mass will be integral 2r by pi by center of mass of this into dm by integral dm. R is changing from 0 to capital R. Two by pi 0 to capital R. What is R? What is dm? 2m by capital R square into R dr. Did you understand what I am doing? Let me just derive the result. 4m by pi r square 0 to r square dr, 2m by r square 0 to r dr. I know where you will be feeling doubt. Just tell me, am I correct or not? Are you feeling doubt here? Why did I put this value here? I have the formula integral y dm by integral dm now. Do you have this doubt? I am guessing.
Yes.
See, because Haripriya, why I have put this one? This is actually the center of mass of this ring. And I have told you earlier, what is center of mass? Center of mass is the point which is the point at which the whole mass of the body is supposed to be situated. Now I am assuming this ring, the mass of that ring means the center of mass. Ring center of mass is lying at this point. Now I am trying to find out the center of mass of the whole disk, means taking the y center of mass of each body and its position. Okay, na?
Yes.
So that's why I'm taking its center of mass, its position. Y1, y into dm by integral dm, because I'm taking dm as this ring. So y point, I have to take that point where the whole mass is situated, is situated for this whole ring. That's why I've taken y as 2r by pi. It's 2 by pi into r cube by 3 r square by 2. Four r by 3 pi. Are you getting correct result? 4r by 3. Easy na? This is how we actually find out the center of mass. But again, this is just to show you how we are getting it. The derivation is not important. If you are feeling it difficult to find out, to understand this derivation and all, if you are having doubt, you can ask me now. If you feel it's a little bit confusing, want to leave, you can leave the derivation, because no one will ask you derivation. But this is the process. These derivation you won't find anywhere. Won't give. At max, they can give you the ring one, but this part they won't tell. Okay.
So we can use this method for
For all everything. I have shown you these methods just in case they give you questions, good quality questions in advance or somewhere else, that in Olympiads also. If they give these kinds of questions, you must be able to solve them by using integration, because they may give some question where the mass per unit area, this mass per unit area I have found, but they may give that it's changing with something, changing with radius rho, that in that particular case you should know how to apply that rho value, integrate. See, one very easy, I'll show you one very easy question. One time they asked in JE main, it's just memory based. If you know the result, you'll get the answer. Let me show you. Saying, sir, we don't like this class. See this one. See, direct result, no? But after this, I'll tell you one very interesting method. To find out the center of mass of cavity. This one is okay, na? This is just a result. Position of center of mass of a uniform semicircular y of radius r is given by this formula 0, xr by pi.
होगा ना
हाँ 2 होगा, because we know this result. It's 2r by
डायरेक्ट
pi.
x की वैल्यू मान
That
Or
yes, it's 2 only. So the value of x is 2. That's all. Over. Sometimes they give this kind of questions also.
आसान
बहुत आसान है. This one is interesting that I'm going to tell you, na? Center of mass of cavity. Sometimes they ask you these kinds of questions. Hence, there some sphere is there. This is a sphere, whole sphere, solid sphere. What they have done, they have created a cavity here. Cavity means the hole. Okay. They have created a cavity. Now they ask what is the center of mass of the body with the cavity. Means this system, na, for this mass they want. Center of mass. Got my point? What I'm trying to say?
yes, sir.
Now, for these kinds of questions, how we do? We assume this is actually made of two different bodies. One is the whole body, whole solid one. And the other is a smaller one, of which the whole is made. Now, what is the concept? Here in the question, they will be giving you the density, means mass per unit area, that they will be giving you. Otherwise, if they don't give you, on the basis of the information, you can find out the mass per unit area. Suppose they have given the mass of this remaining system is small m, and the radius is r, capital R, and the radius of this is small r. In that case, how you will find out rho? Rho will be mass by This is sphere 4/3 pi into capital R cube minus small r cube. Actually, I don't want to give you sphere. Okay, na? You know the volume of sphere. The density I have found, mass per unit. Actually, don't think this is a sphere. Take it as a. If you want to think it as sphere, okay, not a problem. But in this case, we have to find mass per unit volume. Okay, so density I have found. Understood? Because the mass of the remaining part they have given, and the volume of this remaining part is 4/3 pi into capital R cube minus small r cube. 4/3 capital R cube is the mass of this total body sphere, and the mass of this smaller one is 4/3 pi small r cube. That will be minus from it. So that will be the total volume. Clear? Now, since you have found out this density, now what is the concept? This body, this solid body, has positive mass density. All positive. This body has the negative mass density. Do you know something about matter and antimatter? Have you seen that movie, Angels and Demons?
Yes, sir, but I've heard of this term.
That movie that you did not watch.
Yes, sir.
These series, Dan Brown. I don't know you have read novels or not. You have that habit. That Da Vinci Code. That movie is also there. Actually, these are very good movies based on novels. That in that movie, the Angels and Demons, that what I'm talking about now. In that movie, they were creating antimatter. Now they have suspended this antimatter using the battery. Why? Because this, if this antimatter, what is the property of this antimatter? If this antimatter comes in contact with the matter, they collide. They combine with each other and make it a neutral body. Means like it's like positive charge and negative charge, they combine and they make neutral body, na? But when they make it neutral, a lot of energy is released. So the terrorists were trying to use it as an atomic bomb, as a not atomic bomb. It was trying to use it as a bomb, because when matter and antimatter collide, it will create an explosion. But my intentions is to explain you matter, only the thing when matter and antimatter they collide, they combine, they create a void there. We have to assume this is matter and that is antimatter. Okay, understood? So when we keep this negative mass density at this particular place on the solid one, it creates a hole. Understood?
Yes, sir.
Now, how do we do what we have done? We have created two masses. Now, actually, in reality, what is this? This is positive mass density. This is negative mass density. The center of mass of this originally was at this position, means here, 0, 0. And the center of mass of this is at position capital R minus small r. This position. Capital R minus 0. So you will calculate the center of mass of this whole system as x center of mass is equal to m1, the mass of the solid body, this is m2, m1 x1 plus m2 x2 divided by m1 plus m2. Basic formula that you have. What is m1? Mass of this whole body, rho into 4/3 pi into capital R cube. Its center of mass is at 0 here. Its center of mass is at capital R minus small r comma 0. Plus, what is its mass? M2 will be minus rho into 4/3 pi small r cube. Minus rho into 4/3 pi small r cube into capital R minus small r divided by m1 plus m2 is rho into 4 by 3 pi capital R cube minus rho into 4 by 3 pi small r cube. Understood? So the result you will be getting, now you will be getting result. It will be, you can solve it na, easy. The answer will be rho into 4 by 3 pi r cube into capital R minus small r. Capital R cube minus small r cube. Like this kind of result you'll get. But the sign is negative. You are getting. What is the meaning of this? The center of mass of this system lies somewhere here, left, at a distance of this. If I say this is T, X center of mass, it will be lying somewhere here, negative. This point. Understood?
Yes.
Now, this is the basic way of doing it. But I'll give you some shorter result for this, shortcuts. You understood the concept now? What we do? We create matter and antimatter like this. What are the shortcuts? In this case, if it was a sphere, it will be the center of mass of the original one into its volume, V1 into X1 minus V2 into X2 divided by V1 minus V2. Why I am doing it? Because see, if you remove this density rho, nothing is going to change. We are left with the volume only. This is the volume V1 of this body. This is the volume V2 of this body, second body. Again, this is V1. This is V2. This is X1, center of mass of original one. This is X2, center of mass of the second one, where V1 and V2 are volumes. V1 is the volume of whole body. V2 is the volume of cavity. Okay, this is shorter result. This is the case when they have taken as volume, solid body they have given. This is one shortcut you can use. In that case, you need not worry about the negative mass density and positive mass density. Just take its volume, find, put their center of mass values according to the system and just minus them. And if we take the areas, if we take a disk type, means area, you can use X center of mass is equal to A1x1 minus A2x2 divided by A1 minus A2, where A1 is the area of whole solid body, A2 is the area of cavity. I'll give you one question very quickly to make you understand this one. You understood this concept now? It's very interesting one. Try solving this question now. Okay, only in the next class, I'll tell you about the motion of center of mass. Very interesting questions are formed there also. Try this uniform lamina. Lamina means it's an aerial part, area. It's 2D figure, not 3D. Achha, tomorrow class won't be there because tomorrow is public holiday, na? It's 15th August, Independence Day. So happy Independence Day to you all. है ना? तो कल छुट्टी होगी, कल क्लास नहीं होगी, कल तुम लोग एंजॉय कर सकते हो. Can enjoy as much you want. It's your freedom day.
So VMC, they have given us online test and they've named it Freedom from Fear. Even on August 15, they're not giving us freedom.
PW का भी ऑनलाइन टेस्ट ओपन हो गया है.
They won't leave you actually, but I am giving you freedom. Don't tell me anything.
प्रैक्टिस टेस्ट दे दिया, उसका टाइम पीरियड है सुबह है 10 बजे.
Actually, they don't want
टाइम
to
पे
give
करना
you.
है.
It's your freedom. How you want to utilize
कौन
it,
सी
it's up to you.
freedom?
Is it customary you have to give the test on that day only, or you can attempt it later?
सेम टाइम पर ही है, उसी टाइम पर देना.
अच्छा, फिर
लाइक
उसके
एक
चला
ऑनलाइन
जाएगा.
क्लास नहीं, एक ऑनलाइन क्लास वो शेड्यूल करेंगे, उनके सामने वीडियो ऑन करके देना है.
अरे बाप रे, तो डर नहीं
चीटिंग
लगता
होनी
तुम
चाहिए
लोग
ना.
कोई देख रहे, डर नहीं लगता कोई देख रहा है लगातार
नहीं,
तुमको?
10th में बहुत कुछ हो गया था.
10th में ही सब सहज चुके हो तुम लोग हैं.
अरे 10th में इन्विजिलेशन में ऐसे करते हैं ना.
मुझे नहीं पता था ये सब होता है तुम्हारे साथ. मतलब ये
नहीं
प्रॉक्टर बेस्ड सिस्टम जो है ना, वो उसमें तो होता है वीआई ट्रिपली में.
देखो,
लेकिन
लाइक एक ऑनलाइन क्लास जूम पे शेड्यूल करेंगे, 40-50 लोग जूम पे ही अकोमोडेट कर सकता है वो.
तो राधिका, मतलब हर एक एग्जाम, एक बच्चे के लिए एक एग्जामिनर थोड़ी बहुत सारे बच्चों को
नहीं
देखने होंगे
नहीं,
ना. हाँ.
हाँ देख तो रहे होंगे, बट 2-3 इन्विजिलेटर होते हैं, रिकॉर्डेड होती है वो.
ओह,
तो वो देखते रहेंगे. चीटिंग करनी क्यों
तो चीटिंग तो
है?
तुम
100
लोग
तरीके.
कर ही लेते होगे ना. हाँ, और क्या.
लाइक मैं फोन तो नीचे आराम से रख ही सकती हूँ,
आराम से. तुम लोग इतने इंटेलिजेंट
बट
हो.
नहीं कर रहा हूँ ये. चल मैं तो ठीक ही
ये
दे
तो
दूंगी.
बोलने वाली बातें हैं.
नहीं बट देना है, अरे उसके लिए पढ़ चुके हैं.
पर हाँ, तुम लोगों को है ना एक्चुअली, देखो, मतलब नहीं है. अपने आप को
कैसे
ट्राई
करना
टू
है?
डू योर बेस्ट. ये सिंपल है. मुझे लगता है हरिप्रिया तो लगी हुई होगी क्वेश्चन सॉल्व करने में, बताए वो बात नहीं करती.
तुम्हें साथ में कर रही हूँ,
नहीं,
बट समझ नहीं आ
तुम
रहा.
लोग टाइम वेस्ट कर रहे हो. हरिप्रिया, डिड यू सॉल्व इट?
Sir, I got it as -a/3.
No, but answer I think is a by 6, minus a by 6. I was telling na, he does not waste time. The x center of mass is a1 x1 minus a2 x2, that formula, divided by a1 minus a2. A1 is the area of the,
Yes, sir, it's -a/6.
A1 is the area of the whole body, and a2 is the area of this cavity. It's the radius is a by 2. It's pi a square by 4, right? I'm correct na? Yes. So now this formula you'll apply. Pi a square into its center of mass was 0, means at 0 only, the whole body, original body, minus pi a square by 4 into its center of mass is at a by 2 here, into a by 2 whole divided by a1 minus a2 is pi a square minus pi a square by 4. Now we calculate it, you'll get minus pi a square by 4 into a by 2 into 3 pi a square by 4. Pi a square by pi a square, this will cancel. So it will get minus a by 6. So the center of mass of this cavity will lie here, left, at a distance of a by 6. Means the center of mass coordinates are minus a by 6, 0. समझ गए? This is how you solve it. This is how you use this one. Just be very careful that when you are using this area is the area of the total body taken as a whole. A2 is the area of the cavity. Understood? This is how we do it.
So can we leave?
You can leave. You have your independence. Enjoy. Bye bye.
Thank you, sir.
Bye bye.